In this video, I will show you how to create a web API with ASP.NET Core. We will talk about what a web API is. We will create one using ASP.NET Core and .NET 6. Finally, we will consume the web API from a .NET client application. Let's get into it. What is a web API? First, let's explain the term API. An API is a set of functions that developers use to access different functionalities from third-party software. As developers, we use APIs all the time for tasks such as getting the current time, creating files, and so on. A web API is a type of API that uses the HTTP protocol. HTTP is a protocol that is mostly used for serving web content. When we try to access a website, for instance, we make an HTTP request to a server, and the server sends back HTML content. With Web API, you request a resource on the server. Instead of getting HTML from the server, you will get data in JSON or XML. There are many types of Web APIs. REST API is the most popular type of Web API. It lets you convert any data into a resource that can be read, create, update, or deleted by using HTTP methods like get, post, put, and delete. A resource is something that can be named and identified on the web. RPC is another form of Web API. The client sends a method name and argument to a server, which returns JSON or XML data. While REST is about resources, RPC is about actions. GraphQL is a form of Web API where there is a single endpoint. The client indicates in the body of the request if he wants to perform a query or a mutation using HTTP methods get or post. All the different types of Web API comes with strengths and weakness. This tutorial is about REST API. Let's take a look at the flow of a request. The client makes a request. The request is made to an endpoint, which is a URL. The request uses one of the HTTP methods, get, post, put, and delete, to let the server know which action to take. Get is used for reading data, post is used for creating data, put or patch are used for updating data, and delete is for deleting data. The request can have additional information for the server in the headers. Some requests can have information in the body. The server returns a response with data regarding a resource. The response can have information for the client. The response has data in its body. So the response data can be formatted in JSON or XML, but JSON is the most popular. A Web API can provide a service. You can use the Stripe API, for instance, to integrate payments in your application. You can also use a Web API to create a backend for a mobile application or a single-page application. A Web API can also be used to exchange data between two different systems. Now that we know what a Web API is, it's time to create one. In my last video, how to create a web application using ASP.NET Core Razor Pages, I created an issue tracking web application. I will use the same ID. By this time, we will create a web API that allows CRUD operations on issues. We will expose different endpoints, one for getting all the issues, one for getting a single issues by ID, one for creating an issue, one for modifying an issue, and finally one for deleting an issue. I will be using Visual Studio 2022. If you want to follow along, make sure the web development workload is installed. Let's start by creating the project. In Visual Studio, select Create a new project. Select the template ASP.NET Core Web API. Then click Next. In this dialog, set the project name. I name it Tracking API and click on the Next button. I leave the .NET 6 as the framework. I also leave the authentication type to none. The configure for HTTPS is selected. This enables SSL. The checkbox right here says Use controllers. This means that we will create the web API using the MVC pattern. You can also create Web API using Minimal API, which is a way of creating Web API without controllers. If you never heard of Minimal API, I have a tutorial for that. The checkbox right here says Enable Open API Support. This will allow us to use a tool called Swagger to generate the documentation for the API. Click on the Create button to generate the project. The project is created. Let's take a look at the file generated by Visual Studio. The file name Weather Forecast is a model, which is used to generate a web API that can show the weather forecast. So this was created in the generation process. Program.cs is the entry point of the application. This is where the app is bootstrapped. We will use it to register services for dependency injection. App settings.json is where you store the application configurations, such as connection string, for instance. The folder controllers contains controllers. There is one already created when generating the project. A controller is used to process the request. In the properties folder, there is a file called launchSettings.json. This file contains settings that describe how the application is launched. It is meant to be used only on your local machine. Let's run the project to make sure everything works correctly. The first time you launch the project, you will see a warning message. The browser is complaining because we are using a development certificate that it can't verify. To resolve this issue, I go into the advanced options and I click to accept the risk and continue. As you can see, this is our web API. Thanks to the Swagger, the API is documented. You can see that we have one endpoint for the weather forecast. Swagger also allows us to test the API within the browser. Just by clicking on the endpoint name, then try it out. If I click on the execute button, you can see I get the results. So these are the value returned by the weather forecast controller. Let's get rid of these classes because we are going to create new ones. We will use Entity Framework Core in order to interact with the database. The goal of Entity Framework Core is to use C# classes instead of SQL tables. There are two main approaches when working with EF Core. Database first, where a model is created from a database, or code first, where the database is generated based on the model. We will use the latter. The first step is to create the model. At the root of the project, add a new folder, call it Models. Inside this folder, add a new C# class, call it Issue. This class represents a single issue. In order to describe an issue, first we need an ID. This will be the primary key. Next, we need a title. We also need a description. An issue can have a priority. Let's add an enum named priority. A priority can be low, medium, or high. Then we can add it to the issue model. Next, let's add an enum, name it issue type. It will describe the type of an issue. The possible values are feature, bug, and documentation. Let's add the property issue type. Next, we need to capture the time when the issue was created. For that, add a datetime property, name it created. Finally, add the last property, which is also a datetime, but this time we're going to use a nullable datetime. We name it completed. If this property is null, it means the issue is not completed yet. Otherwise, the issue is complete. Let's add some validation attributes on the title and on the description. The require attribute specifies that these properties must have a value. The model is done. Now we are going to install some NuGet packages needed in order to work with Entity Framework Core. Let's go to the NuGet Package Manager window. Because we are going to use SQL Server as the database, we need to install the package provider for Entity Framework Core. The next package we are going to need is the Entity Framework Core tools for the NuGet Package Manager. This package will allow us to run migrations in order to generate the database and keep the model in sync with the database if we make some changes. To communicate to the database, we need a special object called the data context. This object is used to interact with the database. In the project folder, add a new folder, name it data. Inside this data folder, add a new class, name it IssueDBContext. The DB-context is a class that inherits from a class named DB-context. This class comes from the Entity Framework Core package. That's why we need to add the using directive. Next, we need to declare a parameter in the constructor. The type is DB-context_options. This allows setting some options needed by the DB-context, like the connection string, for instance, so that the DB-context knows how to talk to the database. Next, we need to declare a DB-set. The DB-set is a representation of the table in the database. It will allow us to manipulate data from the table issue. The DB context is done. We are going to register it with the dependency injection container. This way, we can request an instance in the controller. Registration for dependency injections take place in the program.cs file. Use the services property exposed by the builder object. Invoke the method addDBContext. You need to provide the type parameter, which is the issue DB-context. This way, we are adding the data context to the service container, and a new instance of the DB-context will be created per request. The addDBContext method takes an action of DB-context options builder. We can use this to configure the options on the DB-context. That's why we declare the DB-context options in the constructor. We use the method useSQLServer to set the connection string of the database. Let's declare the connection string. A good location for that is the file apps settings.json. Add a new entry, name it connection strings. Because we can have many connection strings, we are going to name it SQL Server. I'm going to copy the value from this file. The connection string points out to my local SQL Server instance. Now the data context is set and ready to be used. But before that, we need to generate the database using migrations. Migrations allow updating the database with the latest changes on the model. If you change something in the model, you want the changes to be reflected in the database. That's where migration comes into play. To use migrations, I'm going to use the Package Manager console. For that, go into the menu, select Tools, then NuGet Package Manager, then Package Manager console. Use the command add migration. A migration name is required. And the output parameter allows to choose the location where migration will be created. The location is going to be data/migrations. If you execute the command, you can see that migrations have been created. This will be used to create the database. If you go back to the Package Manager console, now we can use a command called update database. If I execute this command, it will create the database. To make sure the database was created, I'm going to use an app called Azure Data Studio. This is a tool that allows me to inspect the database. If I go to the database, you can see here I have a database called IssueDB. The first table is for storing migrations, and the second table is for issues. Now we have the database, it's time to create the endpoints. In the folder Controllers, right-click on the folder and select Controllers in the menu. Be careful to select a template from the API controller, not from the MVC. Then click on the Add button. Name the controller Issue Controller, then click on Add to create the controller. A controller is a class that inherits from controller base and contains action which will process the request. The controller base class provides useful properties and methods to help you manage HTTP requests. We will see some of them later. You can change the behavior of a controllers and action methods by using attributes that come from the namespace microsoft.asp.NET Core.mvc. The API controller attribute is used to apply common conventions to your controller, like automatic validation of the model, binding request data to the model, and so on. The route attribute allows mapping requests to actions methods. It can be applied at the controller level or at the action level. The template provided here specifies that we will request the API using the URL API/the name of the controller minus the controller suffix. The controller will have to access the database. For that, declare the DB context in the constructor. This way, we will get an instance of it at the runtime. Let's create our first action method. An action method is a public method that is executed in response to an HTTP request. We are going to create an action method that will be mapped to the HTTP verb get in order to get a list of issues. The method returns an enumerable of issue. We name it get. The name is not that important. We decorate the method with the HTTP get attribute to specify that the method will handle HTTP GET requests. In the method itself, use the context to retrieve the issues and use the method to list async to return the issues. And that's it. This action method will respond to an HTTP request and return a list of issues as the response. Let's run the application. You can see the endpoint with the URL template. Click on it. You can see the description of the endpoint, the expected parameters of the request, and the expected response. To try the request, click on the Try It Out button, then Execute. In the response section, you can see the result of the request. Because the database is empty, we have no data. But let's put a breakpoint in the get method and let's try again. You can see that the breakpoint is hit. We are able to reach the action method with the HTTP GET request. Let's add a new action method that will handle HTTP GET requests with a parameter in order to return a single issue. The method returns an I action result. I name it getById. It has an ID parameter that represents the ID of an issue. We decorate it with the HTTP GET attribute to specify that it will handle HTTP GET requests. But this time, we add an ID placeholder. This makes the action to respond to requests that have the ID at the end of the URL. In this case, the URL will be API/issues/some issue ID. The ID in the URL will be bound to the ID parameter of the method. Now I get the issue using the context. If the issue is not found, I'll return a not found result using the method not found. Otherwise, I'll return an OK object result using the OK method. The not found will generate a 404 status code in the response, whereas the OK will generate a 200 status code in the response. In case you wonder where these methods come from, they come from the controller base class. Because we can return two types of response, that's why we return an iAction result. We can enhance the documentation with the attribute produceResponseType. First, to describe that the method returns an issue type with a 200 status code. Then, to describe that the method can return a 404 status code. Let's run the application. You can see the new endpoint. In the parameters section, you can see that the request expects an ID parameter. In the response section, you can see the possible return status code. We are not going to try the request because we still don't have data. We will try out later. So now let's add a method for creating a new issue. The method returns an iAction result. I name it create. It takes an issue object as a parameter. This parameter will be bound to the body of the request. I decorate the method with the HTTP post attribute. In the body of the method, add the issue submitted by the request to the issues collection exposed by the context. Invoke save changes async to propagate changes to the database. For the response, we are going to use another helper method called created@action. This helps return the response with the status code and the location in the header. It takes three parameters: the action that returns a single issue, in this case getById, the ID of the issue as an anonymous object, and finally the issue itself. We can also decorate the method with the produceResponseType attribute to specify that it returns a 201 status code. Let's run the application. You can see the new endpoint. If you click on the Try It Out button, you can fill in the request body, and if I execute the request, you can see in the response section the created issue. Also, if you look in the response header, you will see the URL to retrieve the created issue. Now, let's add a new payload and leave the title empty. If I execute the request, you can see that I get a bad request response. I didn't do anything to validate the issue. The framework takes care of it because of the API controller attribute we set on the controller. Now let's add an action method for updating an issue. The method returns an iAction result. We name it update. Because an HTTP put requires the ID of the issue we want to update and the new issue, we declare an ID parameter and an issue parameter. The ID will be bound to the ID in the URL, and the issue will be bound to the body of the request. We decorate the method with the HTTP put attribute. The ID placeholder specifies that the ID will be in the URL. First, we need to check if there is a mismatch between the ID in the URL and the ID in the body. If it is the case, we return a bad request. Otherwise, we update the issue. and propagate changes to the database. We return a no content result. This will return a 204 status code in the response. Finally, let's enhance the documentation with the produce response type attribute. We specify that the method can return a 204 status code. We also specify that the method can also return a 400 status code. So let's run the application. You can see the new endpoints. First, we execute the get method to get all the issues. We copy the detail of an issue we want to modify. Then let's try out the put endpoint. We update the request body and we set the ID of the issue in the ID parameter. If I execute the request, you can see that it returns a 204 status code. Let's get all the issues again. You can see that the issue has been updated. Now let's add a method for deleting an issue. The method returns an iAction result. I name it delete. It takes an ID parameter which represents the ID of the issue we want to delete. We decorate the method with the HTTP delete attribute. The ID placeholder specifies that the ID will be in the URL. First, we check if the issue exists. If not, we return a not found result as the response. Otherwise, we delete the issue and return a no content result. We enhance the documentation with the produce response type attribute. We specify that the method can return a 204 status code. We also specify that the method can also return a 404 status code. So let's try the application. The new endpoint is shown here. Let's get the ID of an existing issue. Then in the delete endpoint, we specify the ID in the parameter. If I execute the request, you can see it returns a 204 status code. If I get all the issues, the one I deleted is gone. So that's it for the API. Now we are going to create an app that will consume the API. In the solution, add a new project. Select the template console app. Then click next. Give a name to the project. I name it tracking.client. I leave the .NET 6 as the framework, and I click on the create button to generate the project. In .NET, we use the HTTP client class to make HTTP requests. Create a new instance of the HTTP client. Set the base address property to the URL of the API. So you can find the address in the launch settings.json of the API project. We also tell the server that we want the result in JSON format. Then we are going to retrieve all the issues. An instance of HTTP client has methods like getAsync, postAsync, and so on, that allows making requests with a certain HTTP verbs. We use the getAsync method to make a GET request to the API. The method takes the URL path of the endpoint and it returns a HTTP response message object. We can invoke the ensure success status code to make sure the request succeeds. If it is the case, we use the content property and invoke the method read from JSON async to deserialize the content of the response into IEnumerable of issue DTO. So the issue DTO is a data transfer object. It's similar to the model in the API. I'm going to copy all the properties from the model and put it into the DTO. So then we can iterate over the result to display the title for each issue. If there is no issue to display, I display a no result message. To try out the client, we need to run the API first, then the client app. Let's modify the sequence of launch in the solution by enabling multiple startup projects. Right-click on the solution folder, then select Set Startup Projects. Then select Multiple Startup Projects. Tracking API should be first. Set the action to start. Tracking client should be second, and set the action also to start. Click on the OK button to apply the changes. So now if you click on the start to run the application, it will first run the API and then run the console app. If you look in the console app, you can see the issues from the API, and we can also see the same result in the API. This concludes this tutorial. I hope it was helpful to you. If it was, please like the video and subscribe for more. Thanks for watching. See you next time.